this part, we'll be discussing about some problems which are related to the variation of the length and how exactly the length and in combination in totality varies as a function of temperature as well as a variation of in terms of the pressure applied or the force applied. So these are some past year paper questions which have appeared and are significantly slightly difficult to solve it directly. The questions are very easy if you know the tricks. So let's get along with it and try to understand how to solve these questions. So students, now we are in the last part of this particular chapter. So let's try to understand some typical questions that may have been asked in past year questions or past year papers. So let's start off with the questions here. Okay, so here we go with the first question. The first question says, two rods, one of aluminium of length L1 having coefficient of thermal expansion alpha A, and other steel of length L2 having coefficient of linear expansion alpha S are joined end to end. So if I join it end to end, so somewhat like this. So these are the two rods which have been joined end to end, right? So as a result of this, here if I say the first one is aluminium and the second one is steel. So this has a length L1 and this has a length L2, right? Further, alpha A is the thermal expansion coefficient and alpha S is the thermal expansion coefficient of steel. Now we see that it says the expansion in both the rods is same on variation of the temperature. So when we vary the temperature, both have the same value of expansion. So how do we do it? Let's now try to change the color so that it becomes a little more lucid. So here if I say T1, this is T, this is T2. We'll be considering the two end temperatures, right? So what will we get for the first one? If I say the first one, the temperature variation is going to be T1 minus T, and for the second one, the temperature variation is T minus T2, right? Assuming it varies from left to right. Now, how do we proceed to solve this one? We'll say that the length variation, so delta L is going to be equals to L1 alpha A, and then we have delta T for this one, so which is going to be T1 minus T. And the same way for the other steel case is going to be equals to L2 alpha S, and then we have T minus T2. So we have these two. Now if I equate these two, so what will we get? We'll get L1 alpha A T1 minus T, which is going to be equals to L2 alpha S T minus T2. Now let's try to solve this. So if we try to solve this, what will we get? We can write this as L1, or let's do this, that we have T1 minus T divided by T minus T2. This gives us a relation as equals to L2 alpha S divided by L1 alpha A, right? What we need L1 divided by L1 plus L2, okay? So if I have to say that, I need to simplify these two. So as a result, I can also write down this relation as L2 by L1 can simply be given as something like T1 minus T divided by T minus T2, and here you get alpha A divided by alpha S. Now let's add up a factor of 1 on both sides. So if you do that, so what will we get? We'll get L2 plus L1 divided by L1, and on this side what will we get? We'll get T1 minus T divided by T minus T2 into alpha A divided by alpha S plus 1. So once you simplify this expression, you will get the required answer. You just need to invert, you need to simplify this. Add means just open up the parentheses, open up the brackets, and just invert the relation. Once you invert the relation, you will get what is required. Yeah. So let's move on to the second question. This is quite easy. It says 2 liter water at 27 degrees centigrade is heated by a 1 kilowatt heater in an open container, right? So first, let's try to understand how much is the heat that is required. So the required heat, the required amount of heat is going to be equals to M is delta T, that is what we know. So for this case, specific heat of water is 4.186 or 4.2 to be precise. So in this case, what will we get as a result? So we need to change the volume into the mass because we need the mass. So taking that into account, so you'll effectively get 2000, specific heat is 4.2, temperature difference is 50. Yeah, so this is the required amount of heat. Now the time, because it's a 1 kilowatt heater, so power is given to you, so power is going to be equals to 1000 watt. So if power is equals to 1000 watt, so power is going to be equals to the net energy, or it's going to be the energy produced per unit time. So as a result, the time taken is going to be equals to the energy required. So energy required is going to be equals to 2000 into 4.2 into 50. Also there is a loss in heat that is taking place. There is a loss in heat at the rate of 160 joules per second, so that is taking place. So if I say per second effectively, so per second, how do we do it? Energy required is given to us, so this minus 160, so this much joules divided by 1000. So once you do this, you will get an answer which is close to around 8 minutes 20 seconds. So you just need to simplify this and that should give you the answer. Okay, this is even a straightforward question. What does it say? It says 1 calorie is the heat required to increase the temperature of 1 gram of water by 1 degree centigrade. Okay, so when I am saying that this is the way it is defined. So 1 calorie is the heat required to increase the temperature of 1 gram of water by 1 degree centigrade, and this we define in terms of, let's say, from 14.5 degrees centigrade to 15.5 degrees centigrade, and the year marking is done as with respect to 760 millimeter of mercury. So the answer for this is at the rate of 760 millimeter of mercury, and from 14.5 degrees centigrade to 15.5 degrees centigrade. That is the yardstick that is done. Okay, let's go to this one. Not go back. So we have one end of a horizontal thick copper wire of length 2L and radius 2R is welded to an end of another horizontal thin copper wire of length L and radius R. And the arrangement is stressed by applying forces at two ends, the ratio of elongation. So how do we do it? Let's try to put something like this. So they are joined somewhat from here. So you are applying the force here, you are applying the force here. So this has a length 2L, the radius is equal to 2R. Here this has a length L and the radius here is equal to R. You are applying the forces on both the ends. So when you are applying the forces on both the ends, as a result, just using the Young's modulus, we know that the Young's modulus is the same copper wire, same copper effectively, so Young's modulus value remains same. So Y, we know that is equals to force per unit area divided by the change in length per original length. So if I simplify this, so this becomes F divided by L into, you will get L divided by A. Yeah, so this is what we have. Now it says the ratio of the elongation thin wire to that of the thick wire. So that is, we need the ratio of the delta L's. So from here, what can we say? We can say delta L can simply be given by FL divided by A into Y. So using this, let's take a ratio. So we have delta L1 divided by delta L2. So this is going to be equals to, you are applying the same amount of force, so force does not matter. The length does matter, so you'll have L1. Similarly, the Young's modulus does not matter. The area matters, so this into, you will get YA2 divided by FL2. So FY goes off. So you will get what? L1 by L2, and this is A2 by A1, right? So this is what we get. So if I get this, so what is the next thing that needs to be done? you can just write down the area. Area is going to be pi r square. So if you write down in terms of that, so L1 that's equals to 2L, L2 is equals to L, E2 that is the area of the second case, that's going to be equals to pi r square. Area of the original case, that's going to be pi into 2r square. So what you need to do is just you need to simplify these two. Once you simplify this, that's going to give you the final answer. Okay, coming to the last question. But we have two wires are made of the same material and have the same volume. Mind you, it's the same volume. So if we again use the Young's formula, Young's modulus, so we have force per unit area divided by change in length by original length. So this gives you F divided by delta L, and you have E L in the numerator. Further, it says it has the same volume. So if the volume remains same, so what will we get? Volume is equals to length into area. So how do we write out in terms of length? So length can be written as volume divided by area. So let's simplify that. So if you do it, so what will we get? We'll get F into V divided by delta L into A square. So this is what we have, right? Now, you have to take into account the same material. So Young's modulus remains the same. So what all is the things that are going to vary? The thing that are going to vary are the force, obviously the length, and the area. So if I say put this as delta F1 delta L1 A1 square, that's equals to F2 divided by delta L2 into A2 square. So this is what we have. Now, when you are applying the force F, the change in length is delta X. Change in length also has to remain same. That is delta L1 is going to be equals to delta L2. That is the extension in the length remains same. So I just get rid of this particular factor. Okay. So this becomes F divided by A square. This is equals to F2 divided by, it's going to be equals to 9A square. So if I just get this cancelled, so what will we get? The force required is going to be equals to 9 times F. That is option D. So hopefully you understood how exactly the problems need to be solved here, and this basically is the crux of the whole chapter. Yeah, thank you. Hopefully you would have enjoyed listening to whatever we have discussed in the module. Now, if you still feel that there are any particular doubts that you have, so please visit our site www.askIITians.com. In this, go to the discussion board. Here you can find all the topics relevant to your questions. You can post your doubts in these relevant topics. And how exactly you are going to do it? Go to the right hand side corner of your screen. As you can see, you can select the category. The categories are defined here. You can select your category, type down your question. You can use your mathematical symbols as well. Else, if you have the question in the form of an image, you can attach the image, post it. We can assure you that the questions would be moderated and answered between 24 to 48 hours after you post it. So keep posting and happy posting. Thank you. So in this part, what did we discuss about? We discussed about some past year questions, wherein we discussed about some questions related to the variation on length with regard to temperature, variation in length or variation in dimensions with regard to the external pressure and external force. What is some questions related to the stress and the strain and all. So hopefully this would have cleared you the doubts about how exactly you can go further about it. You can also understand and read through or listen to the part wherein we'll be discussing about the video solutions, wherein we'll be discussing some past year questions, 30 questions on the past year papers, and that will further help you in understanding what all are the difficult questions that have actually appeared in question papers. This was just a brief about it. So just to summarize as to what all did we understand in this whole chapter, we started off by understanding about what is elasticity. What is the difference between an elastic material and a plastic material? An elastic material basically comes back to its original state after you remove the force, whereas a plastic material does not. Then we went on and tried to understand about the different types of bulk modeling. We have Young's modulus, we have bulk modulus, and we have hydrostatic modulus as well. So then after that we got into the definition or the explanation in terms of a relationship between stress and strain. The stress strain curve gave us useful insights about the different types of materials, whether it's a brittle material, whether it's a tough material, whether it's a ductile material. That told us about the difference between a plastic and a steel using the context of toughness. Finally, we also got along and we got to know about the variation in length with regard to temperature. And we also got to know a relationship between the force and the temperature. That is, in terms of force, how exactly we can write down in terms of the temperature. So this was all that was covered. Hopefully this would have helped you and made you understand about the whole topic in much more detail. If you still have any doubts, you can come along and discuss further in the batch discussion.